Hello everyone, it's time to talk about this free response question. This was question number 6 from the 2014 AP test. This is a non-calculator question and it's one that's dealing with slope fields. So let's take a look. They say consider the differential equation dy over dx equals that thing. Let y equal f of x be the particular solution to the differential equation with the initial condition of f of 0 equals 1. The function f is defined for all real numbers. A portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. So in this situation, first thing I'm going to do is check to make sure that they didn't do anything goofy with the scale, and they didn't. These notches represent 1. So if I go through the point 0, 1, all they're asking me to do is to try to continue a curve that goes through the point 0, 1. And there's some gray area to how your solution is going to look to this. They do give you some grace here, but you would want something that's going to look approximately like that. And so if you had anything that was generally in this shape that went through the point 0, 1, they would be giving you credit for that. So that's part A, that's all there is to it. Part B says write an equation for the line tangent to the solution curve in part A at the point 0, 1. Use the equation to approximate f of 0.2. So let's think about what we know about a tangent line. In order to write the equation of a tangent line, we have to have a slope and a point. Well, we already know a point. We know that we're going through the point 0, 1 because we have to be tangent to this curve at 0, 1. So our point is 0, 1. And if I'm doing this on the AP test, I'm going to write this out because chances are you're going to get points for recognizing that this is the point that you care about. This bit is going to be trickier. This, we have to deal with this thing up here. Except that we know what the slope is. The slope is dy over dx equals 3 minus y multiplied by the cosine of x, which means that your slope is going to be 3 minus 1 multiplied by the cosine of 0, which is 1. And so we end up with 2 times 1, which is 2. So we know that our slope is equal to 2. So our equation for our tangent line would be y minus 1 equals my slope multiplied by x minus 0, which means that y equals 2x plus 1. Now, we had not finished this part of the problem because they say use the equation to approximate f of 0.2. So we're going to use this equation to guess what the value of f of 0.2 would be. So we plug 0.2 in as my x value right here. So we'd have 2 times 0.2 plus 1, which would be 1.4. So f of 0.2 is approximately 1.4. If we look at this up here, this sort of makes sense. If we drew a tangent line on this curve, the tangent line would look something like this. If we were at 0.2, which would be about here, we'd be higher than we were before. Our value's at 1.4. That seems in the right general ballpark, and that's what we're going with. Nothing too tricky so far. Then we get to part C. Find y equals f of x, the particular solution to the differential equation with the initial condition f of 0 equals 1. Note that they wrote find y equals f of x. That means that you have to get y all by itself. So this is now a separable variables problem. So for part C, we're going to go back to our original equation that they gave us. dy over dx is equal to 3 minus y multiplied by the cosine of x. And we want to split up these variables. So we would end up with dy over 3 minus y equals the cosine of x dx. And our goal is to make it so that there are only y's, which means that we need to get rid of these dy and dx's. So what we're going to do is take the antiderivative of both sides. This, anytime we have 1 over something to the first power, that's going to be a natural log. So we have the natural log of 3 minus y. And then, because this is minus y, we'd have to divide by -1 because of the chain here. And then the antiderivative of cosine is going to be sine. Plus c. We don't have to put the plus c on both sides because a constant minus a constant is a constant, so I'm just going to put it over on this side. But they asked us to find y equals f of x, which means that we have to get this y all by itself somehow. So let's do some algebra. Again, once you write something out, you want to make sure that your algebra is sound from there on out. So we know that the natural log of 3 minus y is going to equal the negative sine of x minus c. Technically, if I introduced the c right here, I could still put a plus c because I don't know what the value of c is. But since I've written this statement and I'm using it to continue things on, I want my algebra to stay sound. Then if I'm trying to get this y out of here, I can put this into exponential form and say that this becomes e raised to the negative sine of x minus c power equals 3 minus y. And once I have this thing, I need to get rid of the absolute values. That just means that this could end up being the positive version or the negative version of 3 minus y. I'm going to stick with y being values that keep this thing back in the original part of this expression positive. So in order to do that, I can't have y be anything larger than 3. So I'm going to start putting a restriction on my problem saying that y has to be less than 3. Because if y was greater than 3, we'd end up with the natural log of 0, which you can't have. If we look back up at this graph, you notice that my graph never actually gets to 3, which is good. My guess is that it doesn't get to 3 over here either. So in order to do that, or get this broken up, I'm now going to subtract 3. So I have e to the negative sine of x minus c minus 3 equals negative y, which means that I could have that thing. Now, I still haven't finished the problem because I haven't used the initial condition, but in terms of getting y all alone, I've done what's required. If you were stuck and you stopped here, you would get the majority of the points for this problem. But we're going to keep on going because we want to know what c would have to be. So we can find this from a variety of places. I'm actually going to go back over to here. I know that I have the 0.01. And so if I have the 0.01, then the sine of 0 plus c has to equal the natural log of 3 minus 1 divided by -1. The sine of 0 is equal to 0. And that means that c will equal the negative natural log of 2. So I can take this and rewrite this, clean it up a little bit. Y equals 3 minus e to the negative sine of x. And because I'm going to be subtracting c, I'll put a plus because that value is a negative, plus the natural log of 2. And I want this restriction that y has to be less than 3. Hopefully that helps people out with this problem. Don't get intimidated by some of the later bits. The problem in and of itself isn't that complicated, but there are some things dealing with restrictions and finally the constant that can make this problem a little bit trickier than the rest of the problem. Don't sacrifice your ability to do one part of the problem because you're afraid of another part of the problem. Hopefully that cleared up some issues that people were having with this free response question, and hopefully you guys are doing a good job of continuing to get prepped for the AP test. I'm thinking of you all. I hope everybody's doing okay, and hopefully I will be able to see you all soon. Talk to you later. Bye.